Now, the before it notation description, and just one uh, illustration of the asymptotic notation. Basically, the compare the efficiency of two algorithms of their growth rate. The what do you mean by growth rate? The algorithm proportional time requirement is known as the growth rate. The algorithm proportional time requirement, that means the execution time of an algorithm. That the how much time required for execution of an time, and this time of algorithm, the proportional time, actually proportional time requirement is known as the growth rate. In this slide, the one graph is there. There are two axes. One is the time, another is the number of instruction. That means the problem size. The problem size in and time in second. There are two algorithms, algorithm A and B. Compare the efficiency of two algorithms A and B by their growth rate. Two algorithm growth rate, that means the total execution time. That FNA denoted by FNA, another is denoted suffix A, another is FNB, the suffix B. The total time requirement for two algorithms. The first algorithm, A algorithm, the total execution time. How to calculate execution time? Last class I discussed. FNA is equal to n square by 5. Another algorithm, algorithm B, the total execution time 5 into 8. So these two growth rate of two functions are plot in the graph. The graph basically this one. One is the linear, a straight line that passes through the origin. Another is a hyperbolic, parabolic graph. From these two equations, from these two growth functions, FNA equal to n square by 5. This is the parabolic graph. Another is no constant is there, only 5n. No constant 5 is there. There is the straight line, and which is passes with to the origin. So now to compare which algorithm is more efficient than other. A more efficient than B, or B more efficient than A. Look at the graph. A is parabolic and B is a straight line. The straight line. So how much time required for this? Say these two graphs they intersect at 25. 25. The problem size is 25. And say suppose the time is t1. Time is t1. After that, the stately increases of algorithm A and state line to step by step increases algorithm A. Like which one is more efficient? Now, after 25 problem size, the time is more required for algorithm A, but algorithm B, the constant time is required. Like one algorithm is most efficient, A or B? The time is constantly increases. This algorithm is most efficient. So in this example, algorithm B, the required time is 5 into n. That is the minimum time. It is the most efficient of the algorithm. Then A, B is a most efficient than B. Now some of functions, growth rate functions are mentioned in this slide. Before discuss of the each and every growth rate function, what do you mean by growth of function? The algorithm complexity will be represented in terms of mathematical notation or function is known as the growth of function. The algorithm complexity will be represented in terms of the mathematical function. Mathematical function. That means say Tn equal to 2n square plus 5n plus 3. This is not in terms of the notation. The growth rate or growth of function expressed in terms of asymptotic notation. So express of algorithm in terms of asymptotic notation order of 1. That means it is independent of the problem size. That is constant problem size. If the algorithm express the time complexity in terms of order of log n base 2, n base 2, the base 2, n base 2. The time requirement for logarithmic algorithm increases slowly as the problem size increases. The problem size n is increases and the time complexity time requirement is slowly increases. And then another growth of function order of n if the algorithm the time complexity expressed in terms of order of n. The time requirement for a linear algorithm increases directly with the size of the problem. That is the linear play increases. And order of n square, the quadratic algorithm increases rapidly with the size of the problem. Size of the problem, order of n square, quadratic algorithm increases. Another is the order of 2 to the power n. If the algorithm time complexity expressed in terms of order of 2 to the power n, that is the exponential algorithm increases to rapidly to be practical. These are the some of growth of function. They are used for express the time complexity of algorithms. Say the graphical representation are right side in this slide. The graphical representation, say order of 1, the constant time complexity, and order of log n, order of n, order of n square, and order of 2 to the power n, the exponential form. Okay. Now, in this slide, there are 9 asymptotic, 9 growth of functions are mentioned. 1, 2, 3, 4, 5, 6, 7, 8, 9. The list of growth of functions in asymptotic notation that we often encounter when analyzing algorithm. That very important order by slowest to fastest growing. Order is very important. Order of 1. The first growth of function, order of 1. It's the minimum time. Then order of log n base 2. After the number 3, order of n. This order is actually the slowest to fastest. Good. The fourth order of n into log n base 2. Fifth is a order of n square quadratic, and 6 n square into log n base 2. And 7 order of n cubic equation, exponential equation, then order of 2 to the power n. And the last of this 9 asymptotic notation expression for of algorithm. So suppose one example is there in this slide. If fx is equal to 3x square plus x cube into log x, then fx, what is the value, or what is the expression of fx equal to? Now say the given fx
Theta
is
of
given
n cube.
fx is hello.
Sir, theta of n cube.
এখানে আমরা থিটা বলছি না, এগুলো সবই থিটার মতো দেখতে লাগছে, কিন্তু এগুলো অর্ডার অফ। ওকে, অর্ডার অফ। এখানে কি করে অর্ডার অফ এক্স কিউব এক্স টু দি পাওয়ার কিউব হলো সেটা না, 0 যে 3x স্কয়ার ইজ দ্য ফার্স্ট টার্ম, 3x স্কয়ার প্লাস the second term is x cube into log x. Now 0 less than 3x square less than x cube, 0 less than 3x square less than x cube, and just to similarly it follow that 0 less than 3x square plus x cube into log x less than x cube. 3x square plus x cube into log x lies between 0 to x cube. So fx is equal to order of x cube. How it is possible to briefly discuss later on in Bigo notation. Now the definition of a Bigo notation. All of you know the definition. Say fn and gn to positive integer. Okay, fn and gn to positive integer function, growth of function fn and gn. We say that the fn equal to order of gn if there exists two constant c and n0 such that mod of fn less than equal to c into mod of gn for all n greater than equal to n0. What is the n? The n is the problem size. What is the n0? The n0 is the minimum problem size. The minimum problem size, this is known as the threshold. Okay. In this slide, one graph representation is there. Look at the graph. There are two functions fn and gn. Remember these two functions, positive real growth of function, positive real function. Okay. The positive real function, what is the condition? Express fn equal to order of gn. The condition is the mod of fn less than equal to c into mod of gn. The c is a constant. C is a constant and n0 is also constant. N0 is the minimum problem size, that is the threshold. And these two functions fn and c into gn plot in the graph for express fn equal to order of gn. তোমরা যদি দেখো these two function plot করা হয়েছে, the fn and c into gn. The fn is Bigo of gn means the function if gn is an upper bound on the function fn. fn এর উপরে upper bound means that function gn is an upper bound on function fn. And these two last intersection point, this is known as the minimum problem size. Indicate the minimum problem size. This is known as the threshold n0. Okay. So some common asymptotic functions are as follows and expressed in terms of Bigo notations. The constant function fn equal to 12. Say at the algorithm, how much time is required? At first to find the execution time. After last class how to calculate the execution time from the algorithm So suppose the fn equal to tn equal to 12, and then to express in terms of asymptotic notation. Otherwise, you cannot express the efficiency. You cannot find the efficiency of the algorithm. I বলছি যদি fn equal to 12 or fn equal to 90, any constant number, fn equal to 100, fn equal to 500, fn equal to 30, any constant number, we can express fn equal to order of 1. Order of 1. By the definition of Vigo notation, fn we can express order of 1 and c equal to 12. How it is possible? It is possible, and just to explain, okay. আমি একটা ডক শেয়ার করলাম, ডক ফাইল। তাহলে আমরা কি জানলাম? Vigo notation definition. All of you know the Vigo notation definition. Fn equal to fn, one function is greater than 0, and gn is also greater than 0. That means that two positive real function. If there exists c and n0, n suffix 0, two constant, then the condition is mod of fn, mod of fn less than equal to c into mod of gn. This condition is satisfied, then we can find fn equal to Vigo gn, and express fn equal to Vigo or big order of gn. There are, first condition is the fn and gn positive real function. The second condition, mod of fn less than equal to c into mod of gn. Then we can express the fn equal to order of gn. This is the definition from the definition of the Vigo notation. Okay? Now, say suppose the execution time of an algorithm is 12. আমি যেটা দেখালাম 12. Total execution time is 12. The constant. Then 12, আমি বলছি এখানে স্লাইডে দেখলাম order of 1. Right? It is order of 1. And what is the constant value? So order of 1 যদি হয়, so what is the constant c? What is the value of c? What is the value of n0? Now fn equal to 12, that means say less than equal to 12 into 1, you can express arikina fn equal to 12 less than equal to 12 into 1 less than equal to where here c equal to 12 and gn equal to 1. Then fn equal to Vigo gn equal to order of 1. where C equal to 12. Now this is another example. This is the example 1. Correct example. Correct example, the linear equation. Say Fn equal to, আমরা অনেক সময় এটা এভাবে বলে দিই, Fn equal to 2n plus 5. The total execution time of an algorithm, not 2n plus 5. Execution time. And this execution time expressed in terms of Digo notation. And express efficiency of the, or find the efficiency of an algorithm. The find the efficiency of an algorithm, that means that the total execution time expressed in terms of asymptotic notation. আমাদের asymptotic notation দিয়ে express করতে হবে। বা বললো সে suppose a total execution time of an algorithm Fn equal to 2n plus 5, then to find the Fn expressed in terms of Digo notation and constant C. তো আমরা এরকম করতাম, তোমরা আগেও তোমরা করেছো, অনেকেই করে। Fn equal to এরকম আমরা লিখে দিই Fn equal to order of n ই হবে, কারণ এটা যেহেতু 1 ডিগ্রি ইকুয়েশন, order of n কি করে হলো জানি না, ওই লিনিয়ার ইকুয়েশন 1 ডিগ্রি ইকুয়েশন, তাই order of n. So what is the constant value? The constant value কেউ বলছে 5, কেউ বলছে না 10, ওই কিছু একটা হবে c equal to, but c কি দরকার আছে? Obviously, otherwise in the definition of the Digo notation, which is mod of Fn equal to c into mod of gn. The c and n0 is c is a constant, n0 is also constant, c and n0 both are constant, and n0 is the minimum threshold, and in the definition the gn is the upper bound of Fn. The c is also important, n0 is also important. Find, given Fn equal to 2n plus 5 is the given equation, find the gn and c and n0. What is the value of gn? What is the value of c? What is the value of n0? Now very simple calculation of this. Less than equal to 2n plus 5 less than equal to is using the induction method. Okay, তোমরা যারা ম্যাথমেটিক্স এ পড়েছো দেখতে, induction methods are several induction techniques are there. The simple techniques here is the 2n plus 5n, where n greater than equal to 1. This relation is true or false? দেখো তোমরা এই রিলেশনটা, আমি যে লিখলাম রিলেশনটা Fn equal to 2n plus 5 less than equal to 2n plus 5n, where n greater than equal to 1, that this relation is true or false?
True.
True? Yes, obvious, true. Then m less than equal to 7n. Now just to compare, mod of Fn less than equal to c into gn. So what is the value of c? Now in this relation, say gn equal to n and c equal to 7. And what is the value of n0? N0 is the 1, because in this relation, where n greater than equal to 0, minimum value of the n is 1. This is the threshold. This is the মিনিমাম প্রবলেম সাইজ, তাহলে n0 equal, তাহলে this three parameter, three values of this gn equal to n, c equal to 7 and n0 equal to 1 is indicate to satisfy the big notation definition. Now we can express fn equal to order of gn, order of gn equal to order of n. তবেই আমরা লিখতে পারবো যে fn equal to order of n, যেখানে order of n where the c equal to 7 and gn equal to n and n0 equal to 1. তা তোমাদের মধ্যে কোনো বন্ধু বললো যে স্যার আপনি এখানে 2n plus 5n লিখেছেন, আমি স্যার যদি এটা লিখতাম তাহলে কি হতো না? another way আমি এখানে নিলাম only n. Yes, 2n plus n less than equal to 2n plus 5 less than equal to 2n plus n, where n greater than equal to 5, n greater than equal to 5, then if this relation is true, otherwise not. The 2n plus n where n less than greater than equal to 5, then this relation is true. Now what is the next step? The next step is less than equal to tn, where c equal to 3 and gn equal to n. And what is the minimum problem size? n0. Now n0 equal to, in this case, n0 equal to 5. বলে দিয়েছি দেখেন, where c equal to 3, gn equal to n and n0 equal to 5. Then we can express fn equal to this one. Clear? সবাই বুঝতে পারছো? হ্যালো, তোমরা কি কেউ বুঝতে পারছো?
হ্যাঁ স্যার।
একটু না বুঝতে পারলে একটু বলবে, তাহলে আমি আবার চেষ্টা করব বোঝানোর জন্য। যে ওকে, কারো যদি কোনো ডাউট থাকে তাহলে আমাকে বলবে, আমি চেষ্টা করব। The similarly, say another example, the quadratic equation. বলছি স্যার আপনি তো এগুলো সবই সোজা সোজা করলেন, এটা যদি কোয়াড্রেটিক ইকুয়েশনে যদি দেখান তাহলে ভালো হয়। সে সাপোজ ইকুয়েশন নাম্বার third example, fn equal to third example fn equal to (27) n square plus 16 n plus 25. This is the given equation expressed in terms of big O notation, and also find the c, value of c, and n0. Similarly, less than equal to first step, 27 n square plus 16n plus, there are two ways. The constant 25 is there. তুমি যদি n লিখো তাহলে মিনিমাম থ্রেশহোল্ড হয়ে যাবে সেখানে 25, আর তুমি যদি 25n লেখো তাহলে কি হবে? In this step the minimum threshold start from n equal to 1, তাহলে n greater than equal to 1, তাহলে where n greater than equal to 1. After that, less than equal to 27n square plus 41n. N 41n. Okay. N less than equal to 27n square plus 41n square. Where n greater than equal to, what is the value of this one?
So 1.
Very good. সবাই বুঝতে পারছো কেন 1 is a relation value. The compare the 41 less than equal to 41n square. n cancel. The minimum less than equal to 41n less than equal to 41n square. 41 is cancel. n one side, right, left side is the n and right side is the n square. n cancel. What is the minimum value of it? n is 1. After that, less than equal to, এবার তো সবাই তোমরা করতে পারবে, that is equal to 68 n square. 60y n square, where এখানে c কত না, that is c equal to 68 and n0 minimum threshold is equal to 1 and gn equal to gn equal to n square. Express fn in terms of big O notation. Big O gn is n square. আমরা যে কোনো অ্যালগরিদম at first to calculate the total execution time and then to express and then to measure time complexity of this algorithm, express using any asymptotic notation. I'm just to discuss the first one, big O notation. How to calculate, how to express of an algorithm execution time in terms of big O notation. The several growth of functions are there: the constant function, the linear function, quadratic function, cubic function, exponential function, logarithmic function. Any function we can express in terms of big O notation, and every expression, okay, proof করতে হবে. Not only the express in terms of big O notation, we also find the value of c and l0. Otherwise আমি তোমাদের জিজ্ঞাসা করলাম, বলতে পারবে যে the best case of the double sort time complexity, তোমরা বললে, সবাই বললে স্যার the tn equal to, but tbn is a suffix tbn, that is the best case of the time complexity of bubble sort order of n. How to calculate the best case time complexity of bubble sort, the order of n? Prove it. তখন আমাদের কিন্তু অনেক সময় মাথা চুলকাতে হয় যে কিভাবে এক্সপ্রেশন, হাউ টু ক্যালকুলেট. Very simple. At first to find the total execution time. The total execution time expressed in terms of the n and constant value. n and constant value যে কোনো আমরা ফাংশন সেটাকে এবারে ইউজ করব, সেই ফাংশন the quadratic, linear, constant, logarithmic যে কোনো একটাতে লাইক করব this function, and then to use the asymptotic notation definition, the condition, the big notation, the fn and gn to positive real function. Remember, to positive real function we say that if there exists c and n0 are constant, then mod of Fn less than equal to C into mod of Gn, where n is the problem size and n is 0 is the minimum problem size, that is the threshold. Another important point is, remember, for multiple choice type question aste pare in the definition of Digo notation, the Gn is upper bound of the Fn, upper bound of the Fn. কারণ আমি তোমাদের যে স্লাইডটা দেখালাম সেখানে কি আছে না, Gn is the upper bound of Fn, Fn এর উপরে C into Gn, upper bound, okay, upper bound, not lower bound, upper bound. Now back to আমি আবার তোমাদের PPT শোতে যাচ্ছি. Now is another definition. The another definition is the big omega. The big omega definition here is also two real positive function, Fn and Gn, two real positive function. That means Fn greater than 0 and Gn is also greater than 0, two real positive function. We say that Fn equal to big omega Gn if there exist two constant C and N0, such that mod of Fn opposite of big O notation definition. In big O notation definition, less than equal to the condition, but in big omega, greater than Fn, mod of Fn, they greater than equal to C into mod of Gn for all n greater than equal to n0. N is the problem size, and n0 is the minimum problem size. The n greater than equal to n0. So in this slide, one diagram is there, one picture is there. This is a graphical representation of Fn and Gn plot in the graph. Look at the graph, very interesting. Just opposite of big O notation definition. The big O notation আমরা দেখেছিলাম যে Gn is an upper bound of Fn, but here the big omega of Gn, it means the function Gn is an upper bound on the, not upper bound, here again a statement is wrong, the lower bound on the Fn. In this slide is the last statement is the wrong statement is there. The Gn is an lower bound on the Fn, lower bound Fn, opposite, the lower bound on the Fn. এখানে condition, the very simple mod of Gn greater than equal to C into mod of Fn greater than equal to C into mod of Gn for all n greater than equal to n0. The some common asymptotic functions are there in this slide. The first one, the constant function and linear function. Number one, the Fn equal to 12 equal to big omega 1. And what is the value of C? Now similarly, আমরা প্রুফ করে দেখাবো C হচ্ছে 12 greater than equal to 12 into 1. So 12 into 1. So 1 is the Gn is a 1 and C is 12. The constant is 12. 2n plus 5 greater than equal to 12. 2n plus 5 greater than equal to 2n. 2n. Where n equal to n greater than equal to 1 or 0. Which one is appropriate? The second function, linear function, 2n plus 5 greater than equal to 2n. So আমরা স্লেপ করে গেল।
জিরো
n greater than huh?
জিরোটা মনে হচ্ছে হতে পারে।
Yes, 0. 0 is the minimum threshold. n greater than equal to 0. Okay. The similarly quadratic equation big omega n square, cubic equation the 4n square plus 2n plus 3, the big omega n cube, and exponential is also this equation the order of big omega at 2 to the power n. Okay. Now is the theta notation. The theta notation definition very simple. The first two definitions, that means a big O notation, big O and big omega, these two definition condition combine and then to form the theta notation. আমরা big notation এ big O notation এ কি পড়েছি? The condition is the mod of Gn less than equal to C into if mod of Fn less than equal to C into mod of Gn, and big omega mod of Fn greater than equal to C into mod of Gn. Combine these two equation, combine করলে this is the last left side C1 into mod of Gn less than equal to Fn. This part is the big omega definition, and Fn mod of Fn less than equal to C2 into mod of Gn. This part is the big omega definition condition. These two condition, the big omega and big O, these two condition combine into form the condition of the big theta notation. Here is also Fn and Gn, two positive real function. We say that the Fn equal to theta of Gn if there exists three constant. Here, how many constant are there? Three constant: C1, C2, and N3. Such that the C1 into mod of Gn less than equal to mod of Fn less than equal to C2 into mod of Gn for all n greater than n0, not greater than equal to n0. n0 is the minimum problem size. This is omega threshold. The Fn equal to theta of Gn means the C2 into Gn. In the in this, look at the graph. The C into Gn, C1 into Gn. The C1 into Gn is the lower bound of Fn, and C2 into Gn is the upper bound of Gn. The lower bound and upper bound are both are combined here. The C2 into Gn is an upper bound on Fn, and C1 into Gn is a lower bound on Fn, where C1 and C2 are constant independent of the problem size n. This is the condition. Similarly, we can solve the sum of equations, sum of growth of functions by using theta notation. Express theta notation: Fn equal to 12, theta of 1, Fn equal to 2n plus 5, theta of n, the quadratic equation, cubic equation, exponential equation, the explanation and derivation are there in the lecture notes, which is available in the Google Classroom. Please download the lecture note and solve it. Another is the little o. The little o, there are two functions, real positive function. We say that Fn equal to little o Gn, if there exists. The C is a constant greater than 0, not greater than equal to, greater than 0. C is a constant greater than 0, and the problem size greater than equal to 1. Minimum problem size greater than equal to 1. Now the condition is the limit Fn divided by Gn equal to 0. Limit Fn divided by Gn equal to 0. The limit Fn by Gn n tends to infinity equal to 0. This is the condition. If the condition is satisfied, then we can express the Fn equal to little o Gn. And it means little o means the loose upper bound of Fn. Fn. Loose upper bound of Fn. Look at the picture. Look at the diagram. If little o is actually upper bound, but loose, not tight. And the one in the bottom of the slide, the two functions are there. Two examples are there. The linear equation that 2n plus 5 equal to little o n square. Say your algorithm total execution time is Fn equal to 2n plus 5, and then to express in terms of little o. How it is possible? How to calculate? How to express the Fn in terms of little o? And now I'm just to share the doc file and illustrate it. What is the condition of the little o? The Fn and Gn two positive real function, C and N0 two constant, the C greater than 0 and N0 greater than equal to 1, such that Fn equal to such that limit Fn divided by Gn. Fn is the numerator equal to 0, where n tends to infinity, n tends to infinity. Then we can express Fn equal to little o Gn. Say your algorithm total execution time Fn equal to 2n plus 5. Now to express Fn little o. Very simple. The limit we know, say limit Fn divided by Gn limit n tends to infinity Fn divided by Gn. Now limit what is the value of Fn? 2n plus 5 divided by gn n tends to infinity. Now equal to 0. Now what is the value of gn যেখানে the limit is 0? If say fn equal to 1, the limit is, what is the value of the limit? No, infinity. The n now also infinity. If gn equal to n square, in this situation limit, so just to put the value of gn, n square. Limit two by n plus 5 into 5 divided by n square. N tends to infinity. So what is the value of limit? At 2 by n. The 2 by n, that is 0. That is 2 into 0. Plus 5 into 1 by n whole square. That is also 0 into 0 equal to 0. কি করে লিমিটটা স্যাটিসফাই করলো না, where gn equal to n square.
স্যার হ্যালো।
হ্যাঁ বলো।
হ্যাঁ স্যার বলছি ওই জিএনটা এন স্কোয়ার হলো কি করে একবার বলবেন স্যার?
দেখো আমরা হ্যাঁ, ভেরি গুড কোশ্চেন। জিএনটা আমি n স্কয়ার ধরলাম, আমি স্টার্ট ফ্রম দ্য 1. Okay, say suppose I put the value of gn equal to 1. In this situation the limit is infinity. Say next step, the gn equal to n. Okay, gn equal to n. So now in this situation is also limit, the value of limit is infinity. Just to put the value of in place of gn n, তাহলে কি হবে 2n plus 5 divided by n. Okay, 2n plus 5 divided by,
yes sir
তাহলে what is the value of limit? What is the value of limit? Limit also infinity. Can n tends to infinity, 1 by n, তাহলে 1 by n tends to 0.
yes sir
বোঝা গেল কি? তাহলে আমরা কখন লিমিটটা 0 হচ্ছে না, the minimum value of gn, the minimum degree of n of the gn value is n square. তুমি তুমি বলো যে nq sir is also true. Yes, nq, n to the power 4. Yes, the minimum value of gn is n square. তখন কি হবে? The little condition is satisfied. So now just to express fn equal to little o n is n square. Similarly, another asymptotic notation is there, little omega. Just তোমরা দেখতে কিছুটা দেখবে little omega this symbol is actually for little omega symbols. Where is there? Little omega, small w. Yeah, little omega. Now say small. This is omega, little omega. The Fn and Gn2 positive real function. C is a constant, C greater than 0. If there exists an integer constant minimum threshold problem size n0 is greater than 1, then we can express or such that the limit n tends to infinity Fn divided by Gn equal to 0. Sorry, infinity. Infinity. Okay. The n tends to infinity. Infinity. This is the condition of the little omega definition. What is the definition of the little omega? Fn and Gn, two positive real function, and two constant C and n0. n0 is the minimum problem size, C is a constant, C greater than 0, then such that the limit n tends to infinity, Fn by Gn equal to infinity. In little o equal to 0, limit equal to 0, but in little omega, limit n tends to limit Fn by Gn, limit n tends to infinity, Fn by Gn equal to infinity. This is the definition of the little omega. Little omega. Little omega definition, Fn greater than 0 and Gn is also greater than 0 to real positive integer function, then C and C greater than 0 and n is also problem size, n0 greater than 1, minimum threshold, minimum problem size, then such that the limit n tends to infinity, Fn divided by Gn equal to infinity. Okay. Now, another example. Say your algorithm, the total execution time. At first, to find the total execution time. Total execution time. Say Fn equal to 2n plus 5. 2n plus 5. Now, to express your algorithm, efficiency in terms of little omega. Little omega দিয়ে এক্সপ্রেস করব, এক্সপ্রেস fn in terms of little omega. তাহলে এখানে এক্সপ্রেস in terms of little omega, তাহলে fn equal to little omega gn. Find the value of gn. Find the value of gn. আমরা জানি লিমিট fn. What is the value of fn? The value of fn is the 2n plus 5 divided by gn. n tends to infinity. তাহলে আমরা what is the minimum value of gn? Find and guess the value of gn and put the value of gn and express and find the value of limit infinity. তাহলে gn এর কোন ভ্যালুর জন্য the limit infinity হবে? Start from gn 1, at first to guess 1, then n square, n cube, n to the 4 dot dot dot. তাহলে যদি আমি gn এর ভ্যালু যদি 1 দেই তাহলে কি হবে? limit 2n plus 5 divided by 1. Yes, minimum value. Then the limit value is 2 into n plus 5. Put the value of n infinity. So what is the limit value is infinity. কি বুঝতে পারলে? What is the minimum value of gn or little omega?
1 sir.
No, 1. তাহলে এটাকে আমরা ইনফিনিটি তখনই লিখবো, এটা ইনফিনিটি তখনই হচ্ছে where the value of gn equal to 1. So, what is the fn? What is the value of fn in terms of little omega and little omega? Now this slide is also stop and then to share the PPT. The little omega is over. Now then to start the MCQ on asymptotic notation. Some of MCQ multiple choice question discussed on the topic of asymptotic notation. Okay. Now this one is the first question and second question shown in the slide. The first question: an algorithm is made up of two independent time complexities, fn and gn. Then the complexity of the algorithm is in the order of fn into gn. Max function is there and min function is there. The fn comma gn.
Some
And
max
mean-
of fn and gn.
Very good. তোমার নামটা কি? ভাই তোমার
সাগর।
সাগর, very good. So always to consider the maximum. আমরা করেছি আগের দিন দেখিয়েছিলাম সেই if else এর the second one কে বলবে second one second one এর অ্যানসার কে বলবে little ogn is small o, little o or small o, little o or small o,
Say asymptotically loose.
asymptotically loose. Already I'm in the definition আমি বলেছি যে little o the asymptotically loose. ওকে, তুমি কে বললে? তোমার নামটা কি একটু বলবে? এগুলো আমি কিন্তু নোট করছি।
Say Sagar, sir.
Sagar. Very good. Now another question number 3. The big O notation of the expression the fn equal to n into log n base 2 plus n square plus e to the power log n base 2 is the given equation. This is the fn equation expressed in terms of big O notation. Expressed in terms of big O notation, which one is the correct? Option A, option B, option C, and option D.
Sir, n square.
Are you sure? Are you sure?
No, sir.
কে বলছো তুমি?
Sir, my name is Shubhayan.
Subhaya. The answer is correct. আমি অলরেডি তোমাদের যখন প্রথমে দেখিয়েছিলাম অর্ডার অফ অ্যাসিম্পটোটিক নোটেশন। দেখো অর্ডার, এই যে অর্ডারটা আমি তোমাদের স্লাইডে দেখিয়েছিলাম, this one is the order of one, তারপর log linear equation n into log n base 2 order of n square. This order is very important. Which term of the given expression is the highest time required? Time required is order of n square. This term is the highest degree of the degree term of the equation, given equation. The order of n square is the correct answer. Order of n square is the correct answer. Next is the question number 4. Which of the function is asymptotically smallest? Asymptotically smallest. Cube root of log n base 2. Here is not clearly mentioned base. What is the base of log? Base 2. Log n base 2. Option A or
Option C. C, sir.
C?
So maybe, sir.
And no, this is the wrong answer. The correct answer is the D. Log cube root of log n base 2. ওই অর্ডারে তুমি যদি যাও, এটা কিউ রুট অফ, এখানে n into root n, n into root n. So suppose the value of n is 2. Okay, value of 2 or 4. So suppose the value of n is 2. Sorry, 4. The 4 into 2, that is 8. Okay, আর এটা কি হবে না, log 4 base 2, that is log 2, মানে sorry 2 log n base 2. What is the value of n? N is 4. তাহলে log n base 2, that is 2. তাহলে q root of 2, the q root of 2, আর ওটা আছে কি, তাহলে 4 হয়ে গেছে। দেখো ওখানে আমি বলেছিলাম কত, 4 into 2, that is 8. তাহলে এটা এখানে এলো কি, q root of 2, q root of 2 is minimum, smallest, তাই না? বুঝতে পারলেন আমি কি বললাম?
Yes, sir.
আমি একটা এক্সাম্পল বললাম যে ধরে নাও n এর ভ্যালু 4, তাহলে n এর ভ্যালু যদি আমি 4 এ দেই, ফার্স্ট দুটো টার্ম ছেড়ে দাও, অনেক বড় হবে। থার্ড টার্মটা কত হচ্ছে, n এর ভ্যালু 4 বসালে 8 হচ্ছে,
8 স্যার।
আর d টা কত হচ্ছে, না কিউ রুট অফ 2। কেন আমি বেসটা আগেই বলে দিলাম, লগ এর বেস 2, ঠিক আছে। The correct option is D. And the question number 5, consider the following three claims. Three claims হচ্ছে n plus k to the power n equal to order of n to the power n, where k and m are constant. And এখানে একটা মিস্টেক আছে, যেটা এখানে দেখতে পাচ্ছ যে 2 into n plus 1, it is not correct. The 2 to the power n plus 1 equal to order of 2 to the power n. Another one is there, the 2 to the power 2n plus 1 equal to order of 2 to the power n. Which of the following claims are correct?
Sir, 1 and 2 are correct.
1 and 2 are correct.
Very
Yes,
good,
sir.
very good, very good. It is a gated question. The question number 6, big omega notation provides an asymptotic in the definition, remember it, the c into, মনে আছে তোমাদের?
The lower bound.
Yes, lower bound. The provide an asymptotic lower bound. Upper bound is a big notation. Okay. Now is the question number 7 and 8. The concept of order big O is important because it can be used to decide the best algorithm that solve a given problem. Now, option 1, option 2, it determines the maximum size of the problem that can be solved in a given amount of time. And option 3, it is the lower bound of the growth rate of algorithm. And they both A and B.
Sir,
Sir,
option
option
B.
C.
Option
Sir, C.
C. অয়ন বলছো তো, না কে বলছো?
Yes, sir. Honor.
অনয়।
Sir, I am saying option D.
D.
Yes.
A and B both. No. The maximum size of the problem that can be solved in a given amount of time, the maximum time. কেন ফার্স্ট অপশনটা এটাও কেন বলছো তুমি? এ তো হবে না ভাই, বেস্ট অ্যালগরিদম বলে কিছু এনে একটা অ্যালগরিদম তার বিগো নোটেশন, আমরা এই কনসেপ্টটাকে অর্ডার অফ বিগো ইম্পর্টেন্ট হবে তখনই না যখন হবে দ্যাট ডিটারমাইন দ্য ম্যাক্সিমাম সাইজ অফ দ্য প্রবলেম দ্যাট ক্যান বি সলভ ইন আ গ্রোথ গিভেন অ্যামাউন্ট অফ টাইম। এটা একটাই, বি অপশনটাই কারেক্ট, বি,
Yes,
এ
sir.
বি না। And the question number 8, the big theta notation. এটা তোমরা
Sir.
হ্যাঁ, এটা তোমরা বলেই দেবে। Consider the following function f, just like this is the C function. Name of the function f, the return type int f, and one argument is mentioned in the function, the int n, integer type variable n. The int s equal to 0 while n greater than 1, n equal to n by 2, s plus plus, loop closed and then return s. So what is the asymptotic complexity in terms of n?
Log n, sir.
Sure.
Yes,
Correct answer is log n. Correct answer is log n. না এটা কারেক্ট অ্যান্সার লগ এন কি করে বললে ভাই তুমি?
Sir, n divided by 2 হচ্ছে। যদি আমরা এক্সাম্পল নিয়ে দেখি লাইক 16 ডিভাইডেড বাই 2 8 ডিভাইডেড বাই 2 4 এইভাবে যদি করি তো log of 16
তার কত আসছে এটা
4 আসছে।
সিরিজ জাস্ট টু ফর্ম এ সিরিজ
Yes, sir.
from a series, and how many times of execute of n equal to n by 2?
So it is a log of n plus minus 1 floor value of
না না ঠিকই বলেছো, এটা log n. ওকে, তো কারেক্ট অ্যান্সার ইজ ডি। হ্যাঁ, log n লগারিদমিক সিরিজ ফর্ম করছে। এই যদি দেখো লগারিদমিক সিরিজ। Now what is the time complexity of fn? Another function is there.
so n log n.
Yes, correct, n log n. এটা কি করে হচ্ছে তোমরা একটু যারা বুঝতে পারছো না তারা কিন্তু একটু ফলো করো, যে টাইম কমপ্লেক্সিটি অফ fn ফাংশন fun ফান, তার সেখানে আমরা ওই total execution time, it is also from a series, logarithmic series, and the common factor is there. This is known as the common factor n. যেমন একটু প্রিপারেশন কিন্তু রাখতে হবে, নাহলে কিন্তু কেটে পারবে না। Now is a problem number 11. Another function is there. In n, this is the nested loop. Another example of nested loop. That in count equal to 0, or in I equal to 0, I less than I plus plus, or in j equal to 1, j equal to 0, j minus minus. Count equal to count plus
So
1.
n square.
n square.
Theta of n square. Very good. Theta of n
Yes,
square.
sir.
Theta of n square. এটা একটা n into n plus 1 divided by 2 ফর্মে আসবে। That is n square form. The execution time equation is the n square form equation, quadratic equation with the time complexity n square of theta of n square. Now, last question of the asymptotic notation topic. Last question: which of the given option provide the increasing order of asymptotic complexity of function f1, f2, f3, and f4? There are 4 functions of there. f1 2 to the power n exponent function, f2 n to the power 3 by 2, okay, and f3 n into log n, f4 n to the power log n. সমস্ত লগের বেসিক order, increasing order, option A.
Yes, sir. A will be correct.
Option A মানে সবচেয়ে স্মলেস্ট টাইম হচ্ছে n into log n, হ্যাঁ, n into log n is the smallest time. তারপরে একটু হ্যাঁ, yes, f4, and last one is the f1. হ্যাঁ, yes, correct. আমি যে আমাদের যে স্লাইডটা দেখিয়েছিলাম অর্ডারে slowest to fast, this order correct, option is correct, answer is option A, f3, f2, f4, and f5. Okay, now this topic is over, and some references are there. Last slide of the first part of the module 1. These are some video links are there. সময় পেলে তোমরা এই ভিডিও লিংকস গুলো ক্লিক করে ভিডিওগুলো শুনতে পারো, দেখতে পারো, ব্রাশ আপ হয়ে যাবে। First part of the part of the module 1. Very interesting video lectures are there. Several IITians are discussed the time and space complexity. একবার দেখে নিও। আর আমি পিপিটিটা তোমাদের গুগল ক্লাসরুমে আপলোড করে দেবো আজকে রাত্রের মধ্যে, তোমরা এটাও দেখতে পারো। First part of the module 1. Okay. Thank you. Today
Thank you, sir.
class is here.
Thank you, sir.